Good afternoon, everyone. Am I audible? Can you hear me?
Hello, sir.
Yes, can you hear me?
Now it is audible, sir.
Okay.
Evening,
My screen is visible? Screen is visible or not? Can you? Ma'am, am I audible clearly or?
Yes, sir, it's visible.
Yeah, okay. Thank you. Thank you so much. So,
Yes, sir.
okay, let's continue with the topics. So now we are going to start about decomposition and modularization. So generally, when we have a problem, if you want to identify the solution for that particular problem, we supposed to use the different strategies in order to solve the problem easily. So one of the important strategies is decomposition and modularization. Suppose whenever we have a large problem, the large problem cannot be solved like using the single function or using the single program. That large problem should be divided into smaller subproblems. Then again, every subproblem can be properly interpreted. Then after that, the solution has to be identified for all the subproblems. Finally, the solutions of all the subproblems would be merged together. Then we will get the solution for that large problem. So that is called as decomposition and modularization. So now most of the programming languages like C, C++, Java, all the general purpose programming languages are supporting this feature. That is, the large problem can be divided into smaller modules, and every module can be treated as a subprogram, and that can be combined together. Then we will get a final application or final software in order to solve the large problem. So all the programming languages are supporting that. So for example, if we take C programming language, we are having functions concept. With the help of function. Yes, of course, a program can be divided into smaller functions. Then the functions can be called by the main function so that we can solve the large problem. And also in object-oriented programming languages like C++ and Java and in Python, we are having object concept. So here the object can be every object can be treated as a collection of functions and attributes also. So that also can be divided, and that object-oriented programming concept also can be applicable for solving the large problem. But if you take Java programming language, we will have only object concept for getting the modularity. But in C++ and Python, either we can follow the structure-oriented approach or object-oriented approach, because Python language and also C++ programming language supports both structure-oriented programming paradigm and also object-oriented programming paradigm. So either you can use the functions concept in order to solve the large problem by dividing the large problem into smaller problems. In order to solve the large problem, or you can use the object. It is up to the programmer. So based on the need and based on the requirement, we can choose the approach, whether we can follow the object-oriented approach or whether we can follow the structure-oriented programming approach. It is up to the programmer. Only the Python programming language and this C++ programming language is supporting both versions, but C programming language is completely based on structure-oriented. We can't use the object-oriented approach. Java will support only the object-oriented approach. It will not support the structure-oriented approach. So in which one of the important thing is decomposition. So in the name itself, we can understand the concept behind this decomposition. Decomposition of a problem involves identifying the main features of a problem and breaking the problem into smaller tasks. So that is called as decomposition. For example, if you want to develop an application, then what are the main features of that particular application? That has to be identified. What are the main features of the application should be identified. Then every main feature should be divided into smaller tasks. So that is called as what? Decomposition. For example, if you develop a web application, what are the different features of that particular web application that we have to identify? So for example, if you want to create a web application for banking, so what are the different things? One application or one component has to display the balance amount. One module or one part of that particular application should take care of transaction from your account to another account. One, for example, one module should take care of maintaining of your personal information. So like that, what are the main features of the particular application or particular problem should be identified, and everything should be divided into smaller problem. So that will be treated as smaller task. Okay. So here, then after that, once the task is divided into smaller task, again we have to check that whether that smaller task is possible to divide further. Okay, that has to be verified. Once every task cannot be broken down any further, then the problem is fully decomposed. Okay, so like that, the decomposition levels may be more than one. Okay, for example, first level decomposition, then second level decomposition, then third level decomposition, like that. So first we will have the large problem. The large problem will be divided into smaller tasks. Every smaller task will be divided into again furthermore smaller task if possible. So once every task cannot be divided into further, divided into smaller tasks further, then we can fix that the problem is completely decomposed. So now here what we can do, that every smaller task can be identified as subsystems of that particular application, and every smaller task can be identified as subproblems of that particular application, so that we can easily manage and solve that particular subproblems. Okay, in order to solve that particular problems easily, and in order to manage the subproblems easily, we are doing the decomposition. So here we are having a diagrammatic representation. In this, here we are having the different levels of decomposition. Like we are having the top level. The top level program is divided into four like different subtasks. Okay, for example, task 1, task 2, task 3, task 4, like that. We are doing the first level decomposition. In the first level decomposition, again, there is possibility of decomposition for few modules, not for all the modules, only for few modules, only for few smaller tasks. There is possibility for further level decomposition, so that only those subsystems will be taken, and that will be divided into smaller level tasks. So that is called as what? Second level decomposition. Again, in the second level decomposition, if some modules is possible to divide it further, then again that also can be done. So that will be done at the third level decomposition. So here that large one will be divided into smaller one. Again, smaller one will be divided into again two smaller one. So like that we can proceed. So once the tasks are not able to divide it further, then it is called as fully decomposed problem. Okay, so here we can have n level of decomposition. So we can create a hierarchical structure like that, or tree structure like that. Tree structure modules are called as what? Decomposition modules. So here for dividing the problem and merging the problem into single one, we can follow the two types of approach. Okay, two types of approaches we can follow for dividing the problem into decomposed problems. One is top-down approach, another one is bottom-up approach. So let us have an example of making dinner. Okay, assume that we are in the preparation of dinner for subset of people. Okay, so that here the making dinner is the task. That is the largest task. So that can be done or that can be solved either using that can be divided either using the top-down approach or bottom-up approach. Suppose if you make a dinner, if you follow the top-down approach, so we will follow from like root to like leaves like that. So for example, for making the dinner, so first we are going to identify the different smaller tasks. One is making dessert and making main dish and making starter. Okay, so like that we are dividing that dinner module into or dinner problem into smaller problems, that is making dessert and making main and making starter. So for example, assume that making dessert and making starter cannot be divided into smaller one further, so that will be kept as it is. Then making main dish can be divided into smaller tasks further. One is making meat course and making vegetable course, like veg and non-veg. So like that we are dividing. So again, assume that in the second level decomposition, we have two modules or two sub-problems. One is making meat course and making vegetable course. So assume that making meat course cannot be divided into further. Then, but making vegetable course can be divided into like making mashed potatoes and making other vegetables. So like that we are dividing. Suppose if you follow this approach, then it is called as what? Top-down approach. Bottom-up approach means we can have like mashed potatoes and we can have vegetables, and that can be combined together and that can be treated as a vegetable course. And we can have a meat course and we are having vegetable course, and that can be combined together and that is suitable for, and that is that can be used to create making main dish. And we are having main dish and we are having dessert and we are having starter. So all three combined together and we can create a, or we can combine into a module called what? Making dinner. So this is called as what? Bottom-up approach. So that is dividing large one into smaller one will be referred as top-down approach, and combining smaller one and making into large one is referred as bottom-up approach. So for dividing the problem or for decomposing the problem and for identifying the solution, we can follow either a top-down approach or bottom-up approach. So now in the top-down approach, the problem will be looked as a whole one, and that problem will be divided into smaller sub-problems. Okay, so that is called as what? Top-down approach. Bottom-up approach means, so here we will list or we will identify the set of small tasks you are then after that you will assemble all those small tasks together and we can create a larger task. So that is called as what? Bottom-up approach. So now discuss about the different types of decomposition. So here there are four major categories of decomposition. One is functional decomposition, another one is object-oriented decomposition, then data-driven decomposition, then event-driven decomposition. So there are four types of decomposition: functional, object-oriented, data-driven, event-driven decomposition. So normally that functional decomposition means, so normally this decomposition may be differ based on the programming languages or based on the programming constructs we are using to solve a problem. So based on that, we can have this classification: functional, object decomposition, data-driven decomposition, and driven decomposition. If you take the functional decomposition, so here the system will be divided into set of functions or features. For example, user interface function, data processing function, network communication function, data manipulation function, and data storage function. So like that, the uh, the system will be divided into functions, set of functions. So that is called as what? Functional decomposition. Okay, for example, if you have like all arithmetic operation, addition may be one thing, subtraction may be another thing, multiplication, division, modulus. Suppose if you divide a large problem into smaller functions or features, then it is referred as functional decomposition. Okay, so for example, if you take an application type of problem, then user interface can be a function, data processing can be a function, network communication can be a function, data storage can be another function, data retrieval can be another function. So like that, every task can be treated as function, and that will be arranged. Okay, then that will be arranged together in order to solve a problem. So that is called as functional decomposition. Then object-oriented decomposition means, for example, here if you take the like bank application, so that bank is the real world entity. In the real world entity, we will have set of objects that will be acting as stakeholder for the bank. For example, if you take the bank, customer will be there. In the customer also, we will have the different level of customers. For example, like savings bank customer, current account customers, and loan account customers, and managers will be there, and other cashier will be there, and other people also will be there. So like that, there are number of entities will be involved in that particular application. Suppose if you divide the application based on that entity or based on the objects which are involved in that particular application, then it is called as what? Object-oriented decomposition. For example, the customer, for example, if you take a e-commerce website, okay, we can consider e-commerce website. I think we all very well familiar about this Flipkart, Amazon, like that. If you take Flipkart and Amazon, we are the customers. We are going to purchase some product, and we will order some product, and we will see some product. We will give some review to that product. Like that, we will be involving in different operations. So the customer and also the product will be there. For example, like fridge, fans, and other items. Like that, there are certain products. So that Flipkart website will be divided into like customers unit and products level unit and orders, and also every object will have the different attributes and also different behaviors. For example, the customer will have the different attributes like name and mobile number, email ID, and address. They have a lot of attributes, and also they will have a lot of behaviors. Behavior means we all know that the operations that can be done by the particular object. So normally can modify their, customer can order that, customer can pay the amount for their orders, customer can cancel the order, okay, customer can track the order. So like that, so every object will have different behaviors similar to the name of the product, and it is belonging to which category. So whether it is related to home appliance, whether it is related to food product, so like that. So every product will have the different information. Similar to that, the order also will have different attributes and behaviors. So if an application is divided based on the objects or entities which are involved in that particular application, then it is called as what? Object-oriented decomposition. Then next one is data-driven decomposition. Is completely based on the data or information. Suppose if an application, if a task is divided into smaller units or smaller subproblems based on the data or information, then it is called as data-driven decomposition. So for example, when you have an application, that application may get the data, may process the data files, may process the data from the database, may process the messages which are passed during the runtime of that particular application. Suppose if a module or application or if a system is divided based on the data or information, it is called as what? Data-driven decomposition. Then next one is event-driven decomposition. So normally in the event-driven decomposition, the system will be divided based on the events or actions. Okay. Suppose like whenever an event is occurred, certain actions has to be performed in the system. So that is called as what? Event-driven decomposition. For example, if the user gives some input, then it has to take some action. When the system is generating that output, it has to like take some action. If there is any trigger, then automatically it has to take some action. So based on that, if the systems are divided, then it is called as event-driven decomposition. Okay, if any action is happened, then if some reaction has to be done. For example, normally if you take an operating system, okay, if you take that operating system as a application, or if you take an operating system as a like task, if you do certain actions on the system, then it will perform according to its action. For example, if you click shutdown, then the system will shut down. For example, if you click click a folder, then the folder will be open. So that clicking on folder, pressing the shutdown button, or pressing the power button are called as what? Events or actions. So based on that action, then the event has to be handled. Okay, so certain operations should be done by that particular system. So that is called as what? Event-driven decomposition. So now let's discuss about how to use modularity and decomposition for writing an algorithm, or for creating a chart. Okay, how we can use the modularity decomposition. So yes, I told already, the modularity and decomposition are close related software. Whenever you develop a big software, whenever you design a big software, modularity and decomposition are very, very essential. So we supposed to follow like that is modularity and decomposition. So whenever you solve a large, whenever you be a large problem, or whenever you design a large software. So with the help of modularity and decomposition, programmer can create manageable and testable software unit with the help of steps. Okay, they have to follow certain to create manageable testable software. Here, for few steps follow in order to create manageable and testable software and am I audible now? I had some issue with my network, so now is it clear?
Yes, sir. Now it's clear.
Okay, okay. Thank you so much. Can you see the screen? Is it
Yes.
visible?
Yes.
Okay. So we supposed to follow certain steps with the help of modularity and decomposition technique in order to create manageable and testable software. there are 5 steps we supposed to follow. The first step is, first we have to identify the main problem. Okay, for example, whenever you have a problem, first you have to identify what has to be done for that particular problem. What is the main problem and what is the main goal of that particular software system, and what will be the scope and what are the constraints of that particular problem. Okay, these things should be identified. In the first step, we have to identify what has to be done very clearly. So here we have to identify goal of that particular problem and the scope and the constraints of that particular problem. Then we have to apply the decomposition technique. So as I told already, the decomposition is used for dividing the large problem or system into smaller and simpler subproblems or subsystems using the suitable method and the level of detail. So that is called as what? Decomposition. So after understanding what has to be done for that particular problem, then we will try to apply the decomposition technique in order to divide the problem into smaller subproblems. If there is a possibility, then we have to do it. So sometimes the problem cannot be divided further, so that you can't do it. So the decomposition cannot be applicable for that particular problem. If there is possibility to apply the decomposition technique to that particular problem, then divide the problem into smaller subproblems or subsystems using the suitable method and level of detail. Then after dividing the large one into smaller submodule, then we have to define the interfaces and specifications for each subproblem or subsystem by describing what should be the input for that particular subproblem and what can be the output or what will be the output of that particular subproblem and what is the functionality of that subproblem. Okay, what has to be done for that subproblem. Okay, so that also we have to do it. So here that is the third step. Okay, so for example, when you have a big application, or you can take a simple example like arithmetic operation means addition, subtraction, multiplication, division, and modulus. So for each, for example, for each task, for each subproblem, for addition, the input will be 2 input, output will be 1, and the functionality will be addition. So like subtraction, input will be 2, output will be 1, and the functionality will be subtraction. So like that, we have to identify what are the input for that subproblem and what will be the output of that particular subproblem and what will be the functionality of that particular subproblem, whether output of this particular subproblem should be given to other task. Okay, that also has to be identified. Then after that, so after identifying the interfaces and specifications of each subproblem or subsystem, we have to implement. Okay, we have to write the code. We have to design and implement each subproblem or subsystem as a module using the appropriate programming languages or tools and standards. Okay, so the fourth step is coding of each subproblem. Okay, then final one is we have to test every subproblem, or we have to test every module, every subsystem individually, so to ensure the correctness of the particular subsystem. Then finally, we supposed to integrate all the modules into single one in order to create the full-fledged software. So finally, you have to perform the integration testing. That is, after integration, again you have to check in order to check or in order to verify their compatibility and performance. So these are the 5 important steps we supposed to follow to create a manageable and testable software with the help of modularity and decomposition. So let's summarize again. First, we have to identify the goal of that particular software. Then we have to divide that particular large software into smaller modules. Then the third one is we supposed to identify the interfaces and the specifications by specifying the input, output, and functionality of each module. The fourth one is coding of each module, that is writing the program for each modules using some programming languages. Finally, the test the individual module and integrate all the modules together and test it again to check their compatibility and performance. So these are the different steps we supposed to follow in software design with the help of modularity and decomposition. Okay, so here when we follow the modularity and decomposition, we supposed to uh, face some challenges. In order to address those challenges easily, we supposed to have some best practices. Okay, so we are having some challenges here. So in order to address the challenges properly, we supposed to have some best practices. So the certain best practices and the respective challenges are given. So we supposed to follow, or we supposed to use consistent and clear naming conventions and documentations. This is very, very important. For example, whenever you write a function for calculating the factorial, the function name should be given as like factorial or fact, like that. Simply if you give triple A or triple X, then with the help of name, you can't understand for what purpose that particular function is given. Okay, you can't understand that. Okay, so for example, if you create a function to solve, to identify the factorial, means the function name should be factorial. When you generate the Fibonacci series, the function name should be Fibonacci. When you perform the addition, the function name should be either add or addition. Okay, so like that. So we supposed to use consistent and clear naming conventions and documentations for the small modules and also the interfaces, so that we can have like good readability of that particular software, or even after the development of that particular software, even while debugging, it will be very easy for the programmers or tester. Okay, we supposed to use consistent clear naming conventions and documentation. Then this next one is we supposed to follow proper design patterns and principles. Okay, we are having some set of design patterns and principles. For example, solid design pattern. So this is some kind of design pattern. So in order to improve the quality of the modules and their interactions. Okay, so we can follow proper design patterns and principles in order to improve the quality of the modules and interactions. And we supposed to choose the proper testing methods and tools to ensure the correctness of each modules and also the total software. Okay, so here we have to use the proper testing method and tool in order to ensure the correctness and functionality of each module. And also we have to implement the feedback mechanism when we develop a software, so that code reviews, user feedback, and metrics that can assess the effectiveness of the process. With the help of these feedback mechanisms, we can increase the accuracy and the correctness of the software, and also the software will be more efficient and effective to the end users. So these are the 4 important best practices we supposed to follow in order to design a effective and efficient software. One is consistent and clear naming convention and documentation. Another one is design patterns and principles. Another one is suitable or appropriate testing methods and tools. Another one is feedback mechanisms. These are the important things we supposed to use in the software design. Okay, then next one is modular programming. So the modular programming is also related with decomposition. So modular programming is a software design technique that emphasizes on separating the functionality of a program into independent interchangeable modules, so that every module can have the necessary things to execute independently or individually. So that is called as what? Modular programming. So other names for modules can be like that. Modules can be referred as subprogram, the macros or subroutines or procedure, and functions. So these are the other names can be used for the modular programming. So here these functions, these modules are very, very important, by which we can have a large application, large complicated application into smaller manageable pieces. Okay, so the functions is very, very important. So the function enables the modular programming. Okay, for example, in C, C++, in Python, we are having functions. That function will enable the modular programming feature. So here in function, generally we are having two types of function here. One is program control function, and one is specific task function. One is program control function, another one is specific task function. Here, program, it can be a C program, or it can be a Python program, or C++. Okay, it can be anything. That function will be divided into two types of function. One is program control function, another one is specific task function. So now these program control functions are mainly used to simply subdivide and control the program. Okay, these functions are mainly used to simply subdivide the large program and control the program. We are having the program control functions. So normally these functions are unique to the program being written. Okay, for example, whenever you have a program, in every program, the program control function will be unique. Okay, so that is called as program control functions. So other programs may use similar functions, but here the function's name can be the same, but the content of the functions may be different. Okay, so that is called as what? Program control function. For example, I will explain with you an example what can be the program control function, what can be the specific task function. So after discussing about the specific task function. So in the program control function, it is mainly acting as control program. So this particular function will be mainly used for controlling that particular program. That's why it is called as program control function. The function name can be same, but the content of the functions will be different. So that is called as what? Program control function. Okay. Then the next one is specific task function. Normally these functions are used with several programs. These functions will be used with several programs. That is called as specific task functions. So normally this particular function will be mainly used for performing a specific task, so that it can be applicable, it can be used in different programs to perform that specific task. Okay, so that is called as what? Specific task function. So here the specific task function sometimes also referred as building blocks of the program. So generally most of the specific task function are already coded and tested. Simply we can use it, and you can efficiently write a large program. Okay, so this is a specific task function. Generally, if you take a program, assume that it may be a C program or it may be a Python program, the main function will be referred as program control function. The other built-in functions like we are having square root, we are calculating power, we are having some string related functions. These are related to specific task function. So normally, whenever you write a Python program, in every Python program, we are having the main part and we are having the other user defined function. Okay. So for example, if we have the power function is written in math module. That power function can be used in any Python program. In all the Python program, that power function will perform the same task. Okay, it will be mainly used to calculate the power. SQRT means that will be mainly used to calculate the square root. That's all. So the function of that particular, the functionality of that particular function will not be changed depending on the program. But in main function, so the function name can be main. Okay, but main function, in one program, it will perform different operation. In another program, the main function will have the different operation. So the main function is the best example for program control function, because we all know that the main function is the starting point of your program. Normally, you can take any programming language. That main program is the starting point of the program. So the main program will control all other functions. It may be the built-in function or other user-defined function. All other functions will be controlled by the main function only. Okay, if you want to invoke, so from the main function only you will invoke. So for example, if you invoke an user-defined function, maybe a factorial or power, so that will give some information to the main function. So the specific task function will send some messages, will pass some information to the program control function, but program control function will not send any information to other one. Okay, so this is very important. So the main function will be referred as program control function, and the specific other user-defined function, for example, square root, power, sine, cos, tan, and string-related functions, string length, string concatenation, string reverse, string search, okay, substring. So these are the example for specific task function. So normally, whenever we have a function, we supposed to follow different steps, uh, uh, different steps in order to create function in the programming languages. It is also completely depending on programming languages. Certain things we supposed to create. One is function definition. So the function definition is very, very important. So the function definition is mainly used to define the task of that particular function that will be performed when it is invoked. Okay, for example, whenever a function is getting invoked, that particular statements which are given in the definition will be executed. So that is called as function definition or define a function. So this is one of the important tasks when we want to use the function concept. Another one is the function call. Okay, or call a function. Function call means, so for example, you have created a function called factorial, and we are having the main function. If you not invoke that factorial function from the main function, even though if you have written the factorial function in the program, that factorial function will not work or will not get executed. So in order to execute or in order to invoke that particular factorial function, we have to call that particular function. So the function call is another important one. And based on the programming language, it is completely depending on the programming language, that declaration of a function. Declaration of a function means that is function prototype. Before using a function or before calling a function, we supposed to inform the compiler we are going to create such function. So that is another important task that is called as function declaration. So with the help of function declaration, every compiler will get to know about, so what is the return type of that particular function, or whether that particular function will return some value or not, and what can be the name of the function, and how many arguments we are going to have that particular function, and what are the data types of that particular arguments or parameters. All those things can be identified with the help of function prototype or function declaration. So in some programming language, these function prototype and function declarations are essential, but in some programming languages, from the definition itself, it can able to identify these information. That is, the compiler can identify these four information like return type, name of the function, number of arguments, and data type of the arguments. All those information can be identified or can be collected by the compiler from the function definition itself, so that the function prototype is not mandatory. Okay, so the next one is function communication. Okay, so here how the functions are interacting with each other. Okay, how the functions are sending the messages, or sending the information, or sending the variables from one function to another function. So that is referred as communication among the functions. So as I said already, so here we are having two types of functions. One is program control function and a specific task function. I told that very clearly. Normally, in every program, the main function will be referred as program control function because it is controlling the entire program, and the specific task functions are meant for performing certain tasks. That's why it is referred as specific task function. So here, the program control function normally will not communicate information to each other. Okay, because so normally there will be only one program control function in every program. We all know that. For example, if you take a C program, every C program must have one main function, not more than one main function. If there is no main function, then the compiler will not have the entry point. Suppose if there are multiple main functions, then it leads to ambiguity problem. The compiler will get confusion about where the execution has to be started. So that every program will have one main function and only one main function, so that the program control function generally will not communicate the information to others. Okay. So this is called as program control function, but the specific task functions are constructed in such a way that that has to be communicated between the calling function and the called function. Okay, for example, If you call the factorial function from the main function, the factorial function has to calculate the result, and that has to be sent. The result has to be sent back to the calling function. So the specific task function are constructed in such a way that it is communicating with other program piece or with other program functions. Okay, so that is called as specific task function. So here normally there are certain rules supposed to be used for establishing the communication for a function. So that function may get the information from other function, or the function may send the information to other function. That is, the communication in and out will be there for a particular function. It will be depend on the programming language. The rules will be defined for communication in and communication out for each function based on the programming language, but the concept wise all are same. Okay, so generally that communication between the program functions, the communications sorry, wait a minute. Yeah, the communication can be done with the help of parameters or arguments in that particular function. Normally, we all know that whenever we write a function for that particular function, if you want to give some input, we can pass it via the parameters only or arguments only. So that is called as a parameter passing methods. So here there are four options for data communication. Okay, so one is no communication in with no communication out. Okay, already we are all aware of that the functions categories, like function with argument without return type, like that. Okay, like without argument and without return type, with argument and with return type, and without argument and with return type, and with argument and without return type. So like that we are having functions that is function category like this. So based on that we can classify that data communication option: no communication in with no communication out, no communication in with some communication out. That means function without arguments and with return type. Okay, the first one is function without argument and without return type. Normally the return type will act as communication out. Arguments, that is parameters, will act as communication in. So function without arguments and without return type will be the no communication in and no communication out. No communication in and with some communication out means without arguments and with return type. Some communication in with some communication out means with arguments and with return type. Some communication in with no communication out means like with arguments and without return type. So these are the different data communication options. Okay, so now let's discuss in detail about the program control functions. So here we all know that, as I told already, the main program or main program piece of a particular programming language will be referred as like the program control function. So generally here the identifier name will be the main. Okay, so in most of the programming languages, the program control function identifier name will be the main. So this is for example, this is a unique function, this is a special function, we all know that. So because in every programming language, the main function will act as the starting point of the execution. Okay, this is the place where the execution will be started. So the end of the main function will be the place where the execution will be stopped. So if you have the opening brace, that opening brace of the main function will be the starting point of the program execution. The closing brace of the main function will be the end point of the or stop point of the main stop point of the program. Okay, so here for example, normally this main function will be used for defining the variables and invoking the functions. Okay, so all those things can be defined here. That's why it is referred as program control functions. So generally, when we have the main function will not be prototype. That is, the declaration of the main function will not be there, and also the function call will not be there. So whenever you start a program, the main function will be invoked. Only the definition of that main function will be there. There will be no function call, and there will be no function declaration or function prototype. So the next one is specific task function. As I told already, the specific task function will be used to perform a specific task in different programs. So that is called a specific task function. So normally the syntax of specific task function will be differed or will be varied based on the programming languages. If you take C++, C, C#, and Java, this will be the syntax of specific task function. For example, return type, return value data type, function identifier name, and data type, and parameter variable name, that is arguments name. So like that, then opening brace. So here you have to give set of lines, and return value you have to give. So this is the declaration or syntax of using this function declaration in C, C++, C#, and Java. Okay. In JavaScript, it is completely different. We have to use the keyword called function, then identifier name, that is function identifier name. Then after that, we have to give the variable. Okay, set of variables we have to pass, and a set of lines, and we have to give the return value. So this is the syntax of using the function or creating function in JavaScript. In Python function, we have to use the keyword called def. Okay, we have to use def keyword, def keyword. Then after that, identifier name we have to give. Then we have to give the parameters, then colon operator. Here we don't have opening brace and closing brace. In order to describe block of code for that particular function, we will have like colon operator. After that, we supposed to follow the same indentation in order to define the block of that particular function. Then we have to give set of lines. Then we have to give return value here. Okay, so here in order to use the functions here in a particular programming language, so we're supposed to understand some key terms, or we supposed to focus on these key terminologies. One is braces. Okay, so normally the braces are used to identify block of that particular code. Okay, in C, C++, Java, and JavaScript, we will use the opening curly brace and closing curly brace. So the opening curly brace will be indicating the start of the function, and the closing curly brace will be indicating the end of the function. So the braces will be used to identify the set of statements that are belonging to that particular, that are part of that particular function. Then next one is the name of the function. So here most of the we supposed to use the identifier name for that particular function. So based on that function name only, the function will be identified whenever we call that particular function. So the next one is function call. So normally a function will be invoked whenever the function call is getting executed. Okay, so the function call is very, very important in order to invoke a function. Then next one is the function definition. So here the function definition will have the code that defines what operation has to be done by that particular function. The task of that particular function will be defined in the function definition only. Then function prototype. In the function prototype, like it is the declaration part. So normally it will give information to the compiler. That is the information such as return type of that particular function, name of that particular function, number of arguments of that particular function, data type of that particular function. So everything will be given to the, all this information will be given to the compiler. The next one is identifier name. This is the name of that variables and also name of that particular function. Modularization means how the large program is divided into smaller units. So the smaller units are very easy to manage. The next one is parameter passing. So how we are going to perform the communication. Okay, whether we are having return type and arguments, without return type and without arguments. So there are 4 ways of parameter passing. So like that, so that is called as parameter passing. Then next one is program control. How that main function is written. Okay, that is program control function, and how every specific task function is defined. So these are the different key terms of using functions concept in solving a problem. So now let's discuss the important properties of a modular system. There are different properties. One is independence, interoperability, reusability, scalability, maintainability, flexibility, clear interfaces, and encapsulation. So these are the different properties of a modular system. Independence means, so here the large problem divided into smaller modules, and every module can be executed independently without worrying about other. So that here we will get the independence feature. Okay. So because of this independence, every module can be isolated from other module. If there is one error is happened in one module, that will not affect the other module. Other function will work. For example, sometimes if you take the banking application, only the transfer option will not work. Okay, you can't transfer the amount from one account to another account, but you can able to see the balance, and you can perform certain other information, but some information will not work. So that is called as independence. So the independence enables isolation, so that one failure in one module will not create impact in another module. Okay. Then next one is interoperability. So generally, when we have the modules, that modules may be designed to work together with the help of well-defined interfaces. Okay, so that is possible. The interoperability is possible. That is, the modules can be communicated together with the help of well-defined interfaces. The next one is reusability. Reusability means once the modules are written separately, these modules can be used in many places without writing the code again and again. The implementation of the module is not required in all the places. Simply we can invoke that particular module, then simply we can use it. So for example, since we are having the power function, since we are having the square root function, then simply we are, wherever we want to calculate the SQRT, simply we are using. We are not writing the code for calculating the square root. Simply suppose if you write a factorial function, and if you convert into module in Python, so in many program, you can calculate the factorial without writing the code for the factorial. Only one time it is enough to write. Then after that, we can simply use it. So it will increase the reusability. With the help of reusability, we can able to save the time, we can able to save the cost, we can able to save the manpower, and the testing time will be very, very less. We no need to write the code again and again. We no need to test it. Once a code has been written, once it is tested whether it is working correctly or not, then that is enough. Wherever you want, you can use it. So the reusability is one of the important properties of modular system. Then the scalability. Whenever we want to expand the features or increase the features, then without modifying the existing code, without touching the existing modules, you can add one more module. In that module, you can add the additional functionalities, and that can be attached with the existing software. So that scalability is another important property of modular system. Then maintainability. Maintainability means, for example, if you write all the code in a single main function, or if you write 1,000 lines in a single function, then the management and maintenance of the variables and the code or instructions will be very, very difficult. Since we are dividing into smaller modules, like every functions can be written with 100 lines or like 20 lines like that, so that the maintainability of the code will be very, very easy. Even if you want to update or debug, so everything will be easy here. Flexibility is there. You can easily like upgrade the components without touching others. Flexibility is there. We can have the clear interfaces between the modules in order to have the interaction or communication between the modules. Encapsulation. So here we can encapsulate the internal workings. We can provide only the necessary details. The internal working procedures can be hidden from users, so that it will hide the complexity and it will reduce the dependencies between the modules. So these are the important properties of modular system. So these properties will provide a lot of advantages. So there are some advantages of modularization in programming. Yes, of course, improved maintainability, reusability, better organization, improved testing. Every modules can be tested individually, and that can be grouped, integrated together. We can do it scalability and enhanced documentation. These are the advantages of modularization in programming. Okay, so now let's find out in this. The next one is we can create and use functions in Python. Let's discuss that. Now, if doubt or clarification, you can either you can unmute yourself and you can ask the question, or you can type in like message chat. If you have any doubt, please. Okay, let's start the next topic.
Sorry, sir. Sorry, sir. Sorry, sir. It is audible, sir. Sorry, sir.
Am I audible? Can you hear me?
Now only it is audible, sir.
Yes, sir.
Am I audible now?
Yes, sir. Yes, sir.
Yes, sir.
Okay. I took some water to show that. Okay. Is screen visible? Screen visible.
Yes, sir.
Can you see the screen?
Yes, sir. Creating and using the function in Python.
Yeah. Okay. Okay. Discuss creating and using. Discuss about how to create and use functions in Python. So here, as I told already, a function is a building block of your program, a part of your program. So here if you want to generate a reusable code, then we can go with functions. So this function concept will enable modularity also. So here the functions can be divided into two types of functions. One is built-in function, another one is user-defined function. So the built-in functions means these functions are already defined in the compiler. So we no need to write the code. We no need to write the code here. Those functions are already defined in the compiler. Simply we can use it. The another one is user-defined function. So for the user-defined function, we have to write the code here. Those functions are user-defined functions. So these functions are not already defined in the compiler. So we have to use the code. So that is called as what? User-defined function. Okay. So here in Python, we can have these two types of function, built-in and user-defined. So here, this is an example how to create an user-defined function. Built-in functions, as I told already, simply we can use it. There are a lot of functions are available with Python. For example, mathematical related functions and like string related functions. Lot of functions are available. Simply we can use it. But the user-defined function we have to create. So for creating the user-defined function, we have to follow this syntax. So first we have to use the keyword called def. Def means that is a definition of function. So we have to use def and the name of the function we have to give. And here we have to give the parameters. Okay, within the function, so within the function parenthesis, we have to give parameters. So then colon we have to give. Then after that, we have to write the code of that particular function or statement of that particular function. Then after that, we have to give a return statement. Clear? So now, so this is an example. Print me is a function name. Def is the keyword, and here we are passing an argument called str. Okay. So now, whenever we have a function, the calling of that particular function is very, very important. So here, for example, if you have a function called change me, so here we have to call this particular function from the main function. So now, so here I will write an example using the Google Colab. So here we are having a function. So the function name can be anything. So let's have like add of a comma b, return a plus b. Return a plus b is the name of that particular function. Okay. So now here you have to give like the main function. So the main function is started here, print add of 1 comma 2. So now if you run this code, so now here we will get the output 3. Okay. So now this is the function call and this is the function definition and this is the, for example, like the part of that particular program. Or you can call the function like this. For example, a equal to int of input of entry value, b equal to int of input of entry value. So here we can simply pass a comma b. So based on your user input, it will, so it is enter a value, enter a value. So for example, 23 we are giving, then enter b value, 45 you are giving, then if you press enter 68, okay, we will get that output. So now this is the starting point of main function, then second line. So here we are getting the two input from user. Then in the print statement, we are calling that particular function. Then here what we are, this will invoke this function, then return a plus b means, then a plus b will be calculated and 68 will be returned. Or here you can create another variable, for example, c equal to a plus b. So here you can have like return c. This is also possible. Okay. So now you can give 3, you can give 4, the output will be 7. So this is, so here this is the function definition and this is the function call and this is the user defined function and this is the main function. As per that, this is the specific task function and this is the program control function. Okay. So like that, the main function is the program control function. Okay. Then here, a function in Python, we have different types of arguments. Okay, we have different types of arguments. One is record arguments, keyword arguments, default arguments. Another one is variable length arguments. Okay, that is a function can be called with the help of different arguments. One is record, keyword, default. Another one is variable length arguments. Okay, record argument means whenever you create a function or whenever you define a function, if that particular function has some arguments, when you call that particular function, we supposed to pass the same set of arguments, then only the function will be invoked. Otherwise, it will produce the error. So for example, here we are having a function like this, add of a comma b. Okay. So now what we are having like this. Okay. Assume that here like c equal to add of like 5 comma 4. Okay. So here a comma b is given, then 5 comma 4. Then after that, then if you like print c, so this will work. Okay. For example, now my output will be 9. Suppose here while creating the function, I have created a function with 2 arguments. One is a and b. But while giving the function call, then if I pass only one argument, then automatically it will produce the error called a type error, add missing one record positional arguments. So this is called as what? Record arguments. Record arguments are the arguments that has to be passed to a function. So this is very, very important. Okay. Another one is keyword arguments. So whenever we pass a function, so we can whenever we call a function, we can pass the arguments along with name of the variable. So for example, if you not use the keyword here, we are having print information. One is name and then adds 2 arguments of that particular function. So now if you print the name, so here, even though if you change the order when you call that particular function, based on the name of the variable, it will take in correct order. That is, the caller will identify the arguments by the parameter name. So that is called as keyword arguments, even if you change the order. Suppose here, if you give the values only without the parameter name like age and name, if you give 50 and Mickey, so the 50 will be given to name and Mickey will be given to age. Okay, will be assigned to age. Since we are giving age equal to 50, name equal to Mickey, okay, so based on the name of the argument, so it will follow that order. that value will be taken for the correct Python parameter. So Python function parameter. So that is called as keyword argument. Next one is default argument. The default argument can be created when we write a function definition. Suppose if you create a default value for certain parameters, suppose if you pass the parameter, then the passed parameter can be taken. Suppose if you not pass the value for that particular parameter, then the default value will be taken. So for example, so here what we are using, you are giving b equal to 100. Okay, if you give 5 comma 10, what will happen? So here the past value will be taken for b. So for example, 5 and 10, 5 will be assigned to a and 10 will be assigned to b. Even though if you have some default value as 100, then the past value will be taken in the case of default argument in this situation. Suppose here if you not pass this value, suppose if you pass only one argument, then 5 will be assigned to a. For the b, since we are not passing any value, so the default value 100 will be taken, so that our output will be what? 105. So this is called as functions with default arguments. The next one is variable length argument. That is, you can call a function with the variable number of arguments. So here we are creating a function called biggest, so in which the variable length arguments can be created using the star operators. If you pass 2 arguments, the variable will have 2 values. If you pass 3 arguments, the variable will have 3 values. If you pass 10 arguments, 10 values, then the var will have 10 values. So based on the number of values we are passing from the calling function, then the called function will have the value. So that is called as variable length arguments. So here let us have an example with the variable length arguments. So we can write the code here. Def, we can write a function called display. Okay, so we are using the star operators. So maybe the variable name may be anything. You can have like AAA like that. So AAA is the name of the argument of the display function. So now if you pass 3 argument, you can have it. Okay, we are writing the for loop for I in AAA, print of I. So display 1, 2, 3, 4, and so now it will work. Okay, what will happen? All the values. Suppose if you pass only 1, that also will work. Okay, if you give like 1.5, 6.7, 8.9, 9.0, 6.1. So if you pass this much number of arguments, that also will work. So that is called as what? Variable length arguments. Clear? So these are the 4 categories. One is required arguments. If you not pass the required argument, the compiler or interpreter will show the error. The next one is default arguments. Default argument means if you pass the value, the passed value will be taken. If you not pass the value, the default value will be taken. Then variable length arguments. So here, if you pass 2 argument, it will consider 2 argument. If you pass 3 argument, it will consider 3 argument. So that based on the number of arguments we are passing, it will update it. So the next one is like keyword arguments. So keyword argument means even though if you change the order, so since we are giving the name of the argument in the function call, based on the name of the argument, it will work. Okay, so it will assign the value, then it will work. Clear? So these are the 4 types of arguments that can be used in function. Okay. So here, when we have the functions concept, so here the scope of the variables are very, very important. So the scope means the lifetime of the variable, where a variable can be accessed and where the variables cannot be accessed. The scope of the variable will be mainly used to determine the accessibility of the variable at different portions of the program. There are 2 different types of variables. One is local variable, another one is global variable. Local variable means those variables will be used only within the function and within the local scope of that particular function. It can be accessed. It cannot be accessed outside of the particular function. It can be accessed only inside of the particular function where it is defined or where it is created. So that is called as local variable. Global variables will be defined outside of the function also. Suppose if you have a global variable, the global variable can be used in multiple functions. It can be accessed in main function. It can be accessed in user-defined functions also. That is called as global variable. It can be accessed throughout the program by all the functions. Okay, that is called as global variable. So here we are having some local variable like argument 1 and argument 2. So that argument 1 and argument 2 can be accessed only within add function. And the variable total can be accessed in add function and also in main function. Okay, the total will be the global variable so that it can be accessed in main function and also in user-defined function called add. So that is called as what? Global variable. So suppose whenever we access the global variable, if the local variable also has the same name, we can use the keyword called global. Okay. Suppose we are creating a, for example, local variable with the same name, or if you want to use the global variable, then we have to use global total. Then only it will be updated. It will be reflected here. Okay. So that is very, very important. The keyword global has to be used. Suppose if you not use the global keyword, then the total will be treated as local variable. So whenever you assign a state, assign values or manipulate variables, and if it is assigned to some other variable, then the variable creation will happen as per the Python programming language. So that if you not use the global total keyword in the user-defined function, then that will be treated as local variable. In order to avoid the usage of local variable, in order to avoid the creation of local variable, we have to use the keyword called global. So these are the different types of functions, different types of arguments that are possible in Python. If you have any doubt in this, you can ask me. Then we have one more topic, that is recursion. So we shall start the recursion after your queries. If you have any doubts or clarification, you can ask me. After your clarification, then we will discuss about that. Do you have any doubt?
No, sir.
Okay. Thank you so much. So now let's start the another topic, that is recursion. So this is another important algorithmic strategy or problem solving strategy, that is recursion. So this is one of the programming techniques where a function will call the same function to solve a problem. Okay, so that is called as recursion. If a function is calling the same function, then it is called as recursive function. Some of the problems can be solved with the help of recursive function features like Tower of Hanoi problem and factorial, Fibonacci series, such type of problems can be solved with the help of recursion. So in the recursion, there are two important components or two important things. One is base case, another one is recursive case. Okay, one is base case, another one is recursive case. So here, whenever we write a recursive function, every function will have a base case. That base case will be used to terminate that particular recursion. So this is very, very important. So here a function is going to call the same function. For example, here assume that we are having a display function or this function. Okay, simply we are writing it. Assume that we are printing Python. We are invoking that particular function. So now this is the user-defined function. This is the main function. In the main function, we are calling the disk function so that my output will be Python. Suppose if I give this here, okay, now what will happen? So from the main function, we are calling the disk function. In the disk function, we are printing Python. Again, it is invoking the disk function. This disk function is calling the same function so that it is becoming recursive. So since the function is becoming recursive, the function is calling again and again. So what is it? It leads to recursion error because the recursive function will become infinite. It leads to what type of error? Recursion error. In order to avoid that recursion error, this base case is very, very essential, very, very important. So every recursive function needs a base case. So that base case will terminate the recursion. Without a base case, the recursion would continue indefinitely. So it leads to an error. That error will be the stack overflow error. So that we will get recursion error here. Okay. Then another one is recursive case. The recursive case is a place where we are invoking that particular function call. Okay, this is where the function calls itself with modified parameters, progressively working towards the base case. Okay, so that recursive case has to be written in such a way it has to reach the base case, then only the recursive function will be terminated. So the recursive case also very, very essential. For example, here we are having an example for calculating the factorial. So def fact of n. So this is a recursive function. If n double equal to 0, return 1. So this is the base case. Okay, if n equal to 0 means return 1. So that is the terminating case. So that is the base case. So return n star fact of n minus 1. Fact of n minus 1 is a call which is calling the same function. That n minus 1 means it is going to reaching the base case. That is n minus 1, n minus 2, like every time it is going to be decreased by 1 so that it will reach 0. So that recursive case will be designed in order to reach the base case. Then in the main function, we are having fact of y and print of f. So in a recursive function, the two important cases are essential. One is base case, another one is recursive case. The base case is used to terminate. This recursive case is used to call the same function again and again, but the recursive function is to be designed in order to reach the base case. So now here, yes, of course, we are having that factorial function. So n double equal to 0 is the base case. So here we are having like, for example, function, and here the recursive function is not used. So we are simply calling that particular function. Okay. So in the previous case only, we are having that recursive function. There are certain advantages of recursion. One is simplified code. So with the help of recursive solutions, we can able to create more concise and easier code to understand when compared with iterative solutions. So the problems would be naturally recursive, then only we can apply the recursive solutions. For example, tree traversals, factorials. So this will come under the recursion. We can have the simplified code. Then another one is reduction of complexity. The recursion can simplify the complex problems by breaking down into smaller subproblems, which can be easily to solve the problems individually. The complexity can be reduced with the help of using a recursion concept. So some of the problems can have the elegant solutions with the help of recursive features. For example, tower of an eye problem and tree traversal problem and combinatorial problem can be solved using recursion in order to get the elegant solutions. And there are certain disadvantages of recursion. One is performance overhead. Okay, suppose if you write the recursive function, if the recursive function will produce higher overhead due to the additional function calls and due to the stack memory usage, it leads to performance overhead. It leads to inefficiency when we have deep recursion. Another one is there is possibility for stack overflow if the recursion is too deep, or if there is no base case, if there is no proper base case, it leads to stack overflow. It results in runtime error, and the recursive function will be very, very difficult for debugging. Okay, so these are the disadvantages of recursion. Okay, so now let's discuss about the call stack. So this is one of the important uh, concept we are supposed to understand when we have the recursive function, because the recursive functions uh, will be working based on this call stack. Okay, so generally the call stack is a data structure. So we all know that the stack concept will work based on the principle called last in first out LIFO model. There is last in first out model. The call stack will work. So here in the recursive function, the last function to be added to the call stack will be the first function to be executed and pop off the stack. Okay, for example, in the recursive function, we are giving the function called like factorial of n minus 1, like that. So that will be added into the stack, and again that will be executed as first, because since it is last in first out, so the function call which is added to the call stack at the last will be executed first, and it will be pop off from the stack. Whenever a function is called, then the function call will be added into the call stack. Any functions that are called from within that function then added to the top of the call stack. So here multiple functions can be added to the stack in this way. So here how the recursion and call stack is related. So here what will happen, that is function call stack. When a function is called in a program, the system uses a call stack to keep track of the function calls. So here every function call adds a new frame to the stack whenever a function is invoked with the local variables and return address and the parameters. So particularly in the recursive functions, each call to the functions pushes a new frame into the call stack whenever a function is invoked. Each recursive call creates a new instance of the function with its own set of parameters and local variables. For example, when you give fact of 5, so first time it will give fact of 5, the second time it will pass fact of 4, the third time it will pass fact of 3. So like that it will go. So here we will have the base case and return. When the base case is reached, then the recursion will be stopped and the function starts returning. As recursive call returns, its frame is popped off from the stack and control goes back to the previous function call. Okay. So here, when you have the factorial function, like how the stack will behave for this factorial function, the initial call will be factorial of 5. Whenever factorial of 5 is called, a new frame is added into the stack. So after that, factorial 5 calls the factorial 4, then it will be added new frame into the stack. Then factorial 4 will add factorial 3, then factorial 3 will add factorial 2, then factorial 2 will add a factorial 1, then factorial 1 will add a factorial 0. Then when you have factorial 0, it will reach the base case, then it will be stopped. Then again, all the functions will be popped off, all the functions call will be popped off from the stack. Okay, so each previous calls will multiply the value by the result of the next call and then returns. The frames are popped off from the stack as each call returns. So here, how to avoid the circularity in recursion means it is very, very important. By defining the clear base case, we can able to avoid the circularity in recursion. Okay, so here we supposed to ensure that the recursion has well-defined base case that terminates the recursion. This case would be straightforward and not involve further recursive call. So then only the circularity in recursion can be avoided. By defining the clear base case, the circularity in recursion can be avoided. If you not define the clear base case, then it leads to indefinite execution. It leads to stack overflow error. Okay, so these are the some of the disadvantages or potential issues of recursion. One is stack overflow and memory usage. So since stack overflow already have explained, because of not defining the clear base case, it leads to stack overflow. We have demonstrated that also. Memory usage means every function call consumes stack memory. So if you have multiple recursion, it leads to high memory usage in the stack, which will create probabilistic issues with this limited memory. So that's all about it. I have completed my presentation. If you have any queries or if you have any clarification, you can ask me. If you have any doubt or clarification, you can ask me. Now the forum is opened for discussion. Any questions?
No, sir.
Okay. Thank you. Okay. I would like to thank the management and the organizers and also the participants for giving me this wonderful opportunity to share my session with you all people. I thank all the participants for your patient listening. Thank you, everyone.
Thank you, sir.
Okay.
Shall we wind up the class, sir?
Yeah.
Okay. Thank you all. Thank you so much, sir. Kartika ma'am will connect you, sir.
Shall I leave the session now?
Yes, sir.
Okay. Thank you.